Welcome to part two. Now we're going to talk about graphing. So you set up a good experiment, you have collected some good data. Oftentimes, a graph is the best way to share that data. So, why is that? Well, graph is really a kind of picture. You know what they say, picture's worth 1,000 words, blah, blah, blah. But actually, in science, graphs are often a really good way to convey information because we're kind of lazy. You could give someone a huge data table that has hundreds of points on it, but it's a lot easier rather than sifting through that and looking for patterns to just put those points on a graph and see what the pattern looks like. Is it a straight line? Is it a curving line? Is it no line at all and there's no pattern at all? All those things are a whole lot easier if you put it on a graph. So before we talk about some of the specifics, I'm going to talk about some of the what not to do situations. So some common mistakes with graphing that you want to make sure you avoid. So we're going to look at things not to do. So don't distort your data with continuation bars by not starting at zero or by creating uneven scales. I'll show you what those look like so you know what I mean. So don't do this. You can see we've got little squigglies here. And it's like, wow, these numbers went so high. These two bars were up at 35 million and 33 million. So to save space, we put these little bars. I understand that there's a temptation to do that, but it really it distorts the picture. If you just look at this graph, it kind of looks like the red line here and the blue line are, twice as tall on average as the other ones, but they're really not. If you're comparing 7 million to 35 million, that's like 5 times as tall. And this graph doesn't really show it. So sometimes you'll see that in the middle of a bar. Sometimes you'll see it down at the bottom here. That's not a great thing to do for our graphs because sometimes it really distorts the picture and makes it look like your data tells a different story than you actually measured. This graph might look okay on the surface, but the problem here is the axis, particularly the y-axis, doesn't start at 0. If you look on the left-hand side, every tick mark goes by 10, so 320 to 330 to 340. But if you go to the bottom, that means the x-axis of this graph lines up with about 270 ppm. And the problem with that is if you're reading this graph, it kind of looks like from 1000 to 1800 that the carbon dioxide levels are pretty close to 0 because they're pretty close to the bottom of the graph. That's not true. They're actually pretty close to 280 parts per billion. So that's another thing that for this class, anytime you make a graph, make sure that the axes go all the way to 0. Next, the good news with this one is this is a lot harder to do when you're making a graph on a computer, unless you specifically tell the computer to not do it the right way. You probably won't make this mistake, but look out for graphs that have an uneven scaling. So the x-axis here is fine. Every tick mark goes up by 1, but on the y-axis, we go from 1 to 2 to 4 to 8 to 16. So this gap up here increases by 8, but this gap down here increases by 1. This gap increases by 2. It's all over the place, which means something that looks like a straight line or a curved line may not actually have that relationship. So be careful when you're making your graphs not to do that. Now we're going to talk about the good things to include on a graph. So for a title, every graph needs a title. You can keep it the same as the title for the experiment. The effect of blank on blank. The effect of independent variable on dependent variable. Every graph needs axes, an x and a y axis, and those axes need to be labeled. Make sure you put the variable as well as the units. So for the independent variable, that's always going to go on the x-axis at the bottom. Dependent variable is going to go on the y-axis. And again, don't forget units. Usually, when you're making a graph online, you're going to have to type in the units yourself. It's not going to automatically add those. So be real careful with that. I already mentioned this, but when you're making a scale, you should have even scaling every time you go to a different line. It should be consistent. But because we're going to make our graphs on the computer this year, that's not really going to be a problem for us. Next, what could be a problem, and is probably the most common graphing mistake that I see, is what type of graph to make. In this class, you are only going to make one of two types of graph. One is a line graph, and the other one is a bar graph. But you don't just get to pick which one you feel like that day. The type of graph you make depends on the data. Specifically, it depends on the x-axis or the independent variable. So for example, when you have an independent variable that is measured with numbers, you're going to use a line graph. I'll zoom in on this graph in a second. If you can't read it on your screen, the x-axis has time in seconds. So time is something that you measure with numbers. If you pick two times, you can always pick a time in between them. What comes between 3 seconds and 4 seconds? 3.5 seconds. Of course, that makes sense. So any x-axis that is a range of numbers should have a line graph. You should use a bar graph for any independent variable that is qualitative or something that you don't measure with numbers. So if you look at this, this is a graph of what kind of pet do you own. If you compare the different categories for our independent variable, what number comes between dog and cat? I don't know, that doesn't make sense. What number comes between goldfish and hamster? That doesn't make any sense. So if you don't have a range of numbers on the x-axis, make sure you use a bar graph. That can be a little tricky sometimes because both of these do have numbers on the y-axis, and pretty much every graph we're going to make does have numbers on the y-axis. So you have to look at the x-axis and see, is that something I'm measuring in numbers? Another question you can ask yourself is, could you put the x-axis in a different order, and would it make sense? So if I took this graph here and I scrambled up the times and put 4 seconds over here, and then 1 second, and then 2 seconds, and then 5 seconds, if you scrambled them up, it wouldn't make sense. That should be a line graph. If I took these and I moved rabbit over to the right and I moved goldfish to the left and I flipped dog and cat, the graph would still make sense. So if you could scramble those categories in a different order, then you can use a bar graph. So another thing that you sometimes have to include would be a key or a legend. That's just this little box on the side. But the only time you need that is if you have two sets of data on the same graph. So like this one has numbers of students at different ages, but it also lists whether they worked or whether they didn't work. And if we don't have this key, this legend, we don't know which line is which. So if you're looking at your graph and you have multiple lines and someone might not know which is which, it needs a legend or a key. Also, the good news is usually when you're making a graph on a computer, it'll automatically add that for you. All right, I'm not going to talk too much about conclusions, but once you've collected data, once you've made a graph, it's really good to be able to draw a conclusion. So basically that's saying, what is the graph telling you? What story is the data telling you? Sometimes there may be a conclusion. Sometimes it may be that there's no relationship between the variables you're studying. If you get a graph that's just random points scattered all over the place and they don't look like they follow a trend, that's still a conclusion that there's no relationship between the two variables you looked at. So in general, a conclusion is going to be a description of the experiment, maybe a description of how it was set up, but most importantly, it's going to be a verbal or written summary of the trend that is shown by the graph. These are some general questions, but I'm usually not going to be this specific when I'm looking for a conclusion. I'll just ask you questions like, what is the relationship between these two things? Or what conclusion can you draw based on the graph? Typically, I'm not going to ask you to go into too much detail on that. All right, I did the math. We can't afford the cat. If I gave you a crayon, could you draw a conclusion? We'll practice drawing conclusions in the homework this week. And Don't worry, it's not going to be super detailed. I'm not going to make you write huge paragraphs like the old days. We'll figure that out when we get there. So thanks for stopping back for part 2. If you have any questions, you know how to contact me, and hope to hear from you soon.